going to be browning onions. But first, we need to start cutting up the onion. I've already peeled the onion and cut off the ends. Now I'm going to cut it in half. That way we have a flat surface to use. That way it's not moving on it. We're also going to cut out a V. That way we don't have all the nasty middle in there. Today I'm using a chef's knife to do this because it has a paring part and a nice big cutting part. To cut up the onion, we're going to be following along these lines. This creates a julienne cut. We use a julienne cut because it has more surface area, and that way it cooks more evenly. It's also aesthetically pleasing to the consumers. When we do this, we're cutting at an angle. When you're cutting, you may start crying because the onions has a certain chemical in them that makes you cry. So it's usually good to be in a ventilated area, but we had to turn that off because then you couldn't hear me. And that's a cut up onion. We're now going to add this to our saucepan and start browning it. Deep browning over medium heat. In order to brown, we will be performing a combination of caramelization, which is a sugar and sugar reaction, and a Maillard reaction, which is a sugar and amino acid reaction. Amino acids come from proteins. First off, we're going to talk about how caramelization occurs. Onions are primarily composed of carbohydrates, which is made of fiber and sugar. Onions also contain proteins as well. Now when you get the heat up, the onion cells rupture and the water evaporates. The onions begin softening and releases sugar and proteins from these ruptured cells. The sugar starts to become oxidized and the large sugar molecule sucrose breaks down. It breaks down into glucose and fructose, which are monosaccharides, and they are also reducing sugars. This is where the Maillard reaction begins taking place. Reducing sugars and amino acids begin to react. This is also where we start to get that sweeter smell that we associate with caramelized onions. Then the Midori rearrangement will take place, aka a nitrogen from the amino combines with a glucose. This knocks off an oxygen. This allows a shift base to form, and the two hydrogens from the amino and the oxygen that got knocked off form H2O. We then get the Midori product. This will take about 30 minutes to fully caramelize, and we should have a nice brown color when it's done. The Maillard reaction is also affected by heat and pH. In order to affect the pH and make it cook faster, you need to make it more basic. This can happen by adding baking soda. Heat's a little more harder to control due to the fact you can start burning them. So this has been browning for about half hour, and you can see it has a lovely golden brown going on. And we're going to add this to some ribeye I made. And it should be an awesome meal.